Hello everyone, in this video we're going to talk about graph theory. This is the first video in the introductions to graph theory. In this video, you're going to learn new terminologies related to graph theory, and in the next video, you're going to see more definition and terminologies related to graph theory. So what is a graph in discrete mathematics? So a graph, denoted as a G, consists of two components, V and E, where V is equal to V of G, means that is the vertex set of G, where G is the graph, and it has to be non-empty set. And E is equal to E of G, is the edge set of graph. So each S has one or two vertices called endpoints. A graph can be classified as a finite graph if it has finite number of vertices and edges. And the graph can be classified as infinite graph if it has infinitely number of vertices and edges. So for finite graph, gonna have a finite number of vertices and edges. And for infinite graph, it's going to have infinitely number of vertices and edges. Now let's consider the following graph. So in this graph, you see that there is vertices called V1, V2, V3, V4, and V5, and there are some edges in green connecting two vertices together. Most of the time, what you see is that the vertices are just represented by dots or points. And edges can be represented by line segments, possibly curved. So that means that I can have this type of edge. How could you identify the vertices and the edges in a set? So by definition, the set of vertices is going to be written as V of G, and this is the set of V1, V2, V3, V4, and V5 in this particular case. And for the edges, we use the notations E of G, and we could see that the V1 is connected to V3, V1 also connected to V5. In addition, you have V2 connected to V4, and V3 connected to V1, V3 connected to V4, and V3 also connected to V5. However, the connection between V1 and V3 and the connection between V3 and V1 is going to be the same. So when you represent the set of edges, this is how you're going to present. So I have a subset of V1, V3, and V3, V1 should be the same by the definitions of a set. The order does not matter. Also, V1 connected with V5, V2 connected with V4, V3 connected with V4, and V3 connected with V5. So that's technically how you present it. However, in practice, when you write the edges like this, it's a little bit more tedious to do so. So instead, what you do is that you just represent the connection between the vertices as follow. So you have the edges between V1 and V3, so you're going to just write V1, V3. There's the edge connect between V1 and V5, so you're going to write V1, V5, so on and so forth. So you have V2, V4, V3, V4, and V3, V5. So this is a lot easier, it's more accessible. And when you write something like this, another conclusion you can draw is that the vertices that on the same edge is said to be adjacent to one another. So in this case, what you have is v1, v3, meaning that v1 is adjacent to v3. So on and so forth. So v1, v5, that means v1 is adjacent to v5. And v2 is adjacent to v4, v3 also is adjacent to v4, and v3 is adjacent to v5. What is not adjacent is that you have two vertices and they are not connected by any edges. For instance, v1 is not adjacent to v2, v2 is not adjacent to v3, and v4 is not adjacent to v5. So in this case, you can say that v1 is not adjacent to v2, or v2 is not adjacent to v3, and then v4 is not adjacent to v5. Alright, now we're going to move on to another concept called the order and the size of the graph. So the order of the graph is equal to the number of vertices, and the size of the graph is equal to the number of edges. So the order of a graph is equal to the number of vertices and the size of a graph is equal to the number of edges. Now go back to the example we see earlier. So because you have 1, 2, 3, 4, 5 vertices, the order of this graph is going to be equal to 5. So the explanations for that is there are 5 vertices, and the size of the graph is equal to, so this is 1 edge, 2, 3, 4, and 5. So the size of the graph is also equal to 5, and the explanation is that since we have 5 edges. Now we're going to consider another example where we're going to identify the order of the graph and the size of the graph. So in this case, I have two different graphs. For the first one, there are 1, 2, 3, and 4 different edges, so the order of the graph is equal to 4. And the number of edges is going to be 1, 2, 3, and 4, so the size of the graph is also equal to 4. In this example, you have 1, 2, 3, and 4 vertices, so the order of the graph is 4. And the size of the graph depends on the number of edges. So you have 1, 2, so there are 2 edges connecting A and B, 3, 4, 5, 6, and 7. So there are 7 edges, therefore the size of the graph is going to be 7. So that's it for me in this video. I'm going to move on to the next video, and in the next video we're going to go over more terminologies